Hi, welcome to our Osmosis lab makeup. If you were absent during the actual lab where we collected data, this will help make a lot more sense of what we did in lab instead of simply reading the procedure. It will kind of lead you through what we did in lab. So if you look at what you need to do for your makeup, step one is to actually watch this Edpuzzle. Watch this video. This is for part of your points. And since you missed actually completing the lab, it is required that you watch this video so that you know what the lab's about. Step two is while you're watching the video, I'm going to give you some sample data that was actually collected during lab earlier this week. So in your data tables, you're actually going to use the data from this recording. So you'll actually want to write in any numbers that I go over because this will be your data that you're using for lab. Okay, once we've gone through the whole video, eventually you'll complete the calculations that are explained, you'll graph the data, and then complete the analysis questions. So basically, you're just acting as if this is your data from your lab that you happened to miss, but you're going to complete the lab report just as if this was your actual lab. So it's important to watch, listen, ask questions if you are confused about what the lab's actually about. Okay, so to start, first of all, if after reading the procedure, if you were unclear, basically each group received potatoes. So you can see in these cups, these little plastic cups, there are 3 small pieces of potato. They've been peeled, but it's just regular potato pieces. So there's potatoes in each cup. If you remember from earlier this year, potatoes are high in carbohydrates. And specifically, the carbohydrate is starch. But remember, all carbohydrates are sugars. So it's high in complex sugars, which is starch. And these were all cut from the same potato. Whoops, let me go back. Okay, so what we're going to do in this lab is soak the potatoes in solutions. So the solutions have different amounts of sugar. So basically we made sugar water. So the water that's going to go into this cup over here is just plain water, 0% sugar. So we'll have 3 pieces of potato floating in 0% sugar, just plain water. Okay, so the sugar water we're going to add to this cup is 5% sugar, 95% water. So basically we had the water and we added enough sugar to make it 5% sugar in the water. Same potato soaking in water with a little bit of sugar. Okay, this solution has 10% sugar and water that we'll add to it. This is even more sugary, so we're adding a sugar solution that the potatoes will soak in. It's 15% sugar in the water, and then we put the potatoes in there. And then this one over here is the most sugary with 20% sugar in the water. Okay, so if we go to the next slide here, you'll see before we actually soak the potatoes in these different sugar solutions or solutions of different sugar levels, we're going to take an initial mass and we're going to find out what the potatoes weigh. Okay, so it's hard to see in this picture, but there should be all 3 potato pieces from each cup. So right now I'm measuring the 0% sugar cup. See, it's gone. That's this one. So I'm measuring these potatoes and I'm going to record this on my data table in data table 1. Look at your data table 1 in the column that says initial mass. It should be like right here if you look at this mouse over here. So basically each cup we're going to weigh what the potatoes weigh, or the mass, at the very beginning of the lab. Okay, the potatoes are not all exactly the same size, so it was important to weigh the potatoes in every cup. Okay, so if you see here, this is how our lab got set up. Once we were done weighing what each potato weighs, or each group of 3, see how I have data written in each one. I'll show you the numbers here in a minute. But it's only the initial mass because that was the starting mass of what they weighed before we soak them. So now we've added the solutions, and I added food coloring to the solutions so that we could not forget which cup was which. So like the blue is 5% sugar plus some blue food coloring, green is 10% plus food coloring, 15 and 20. And so this one over here, you can't tell, but it does have water in there. It's just no sugar. Okay, so basically we let these potatoes sit for a good 45 minutes, maybe a little bit longer. And in the meantime, osmosis is happening. And if you remember, in osmosis, Water moves across the cell membranes because the cell membranes are selectively permeable. So water moves from areas of higher water concentration to lower water concentration. So it's going to move towards the side that is more sugary. So basically, by doing this, we're trying to figure out which solution has about the same amount of sugar as a potato. Because some of these solutions, the water will move into the potato if the potato was more sugary. Some of these solutions, the water might move out of the potato if the potato was less sugary. So we're going to see what happens. And if these potatoes gain weight, that means they gained water. And if they lose weight, that means they've lost water. So we're going to weigh them again at the end of the 45 minutes. Okay, but first, let's go ahead and record our data. So get your sheet out. We're just filling in data table 1. Okay, and this was our data. So all of our initial mass for our potatoes was this. So in the 0% water, we had 2.5 grams. In the 5% sugar, that should have been 0% sugar, sorry. In the 5% sugar, it was 3.3 grams to start. And then I've already written in what the final mass was. So it was 3.9 grams to end. So that shows that the potato gained weight. It started out at 3.3 grams and it ended at 3.9 grams. Okay, this one started at 4.6, ended at 4.9. So go ahead and pause the video here so you can fill in your data. And we're going to move on so that we can do the math. So to do this math right here, you're going to calculate what the change in mass was. We want to know what percentage, how much did the potato change mass? Did it gain only a little bit of water compared to how big it was? Did it lose a ton of water? What percent change did it have? So we have to do 2 calculations to do this. Okay, first we have to do the change in mass. We're going to subtract final mass minus initial mass. Okay, so this is set up for you where we have final mass on top. So for example, this last column I already did. I'm going to do 2.7 final mass minus 3.0 initial mass. That's going to get me negative 0.3. That's okay that it's negative. If some of these numbers are negative, leave the negative symbol there. That's important. If the symbol of change in mass, if it's negative, that means it had a negative change. That means it got smaller. If the change is positive, a positive change, that means it got larger. So you do need to keep the negative sign if it's negative. Okay, so you're going to go through for each of these. I'd do 3.2 minus 2.5 equals, and I'd write that right here for my change in mass. Okay, so go ahead and pause the video, and you're going to do that math all the way across. Change in mass equals final mass minus initial mass. Okay, so now if you're still listening, you should have this entire first row change in mass complete with your calculations. Now you need to complete the change in mass, the percent change in mass. So we don't really want the the straight number of how much it changed. We want to know the percentage of how much it changed. So relative to the potato's actual size, how significant was this change in mass that we recorded? Okay, so to get the percent change in mass, you're going to use that number that you just calculated, so this first row, divide it by the initial mass, and then multiply that by 100. Okay, so if you look at my sample over here, I already calculated my change in mass. I did 2.7 minus 3.0 equals negative 0.3, right? That's what I put right here. So to do my percent change in mass, I'm going to do negative 0.3, my change, divided by initial mass, 3, multiply by 100, and I end up with negative 10%. Okay, you can round these to the nearest whole number if you like. But again, if there's still a negative sign, you need to keep the negative because that means that percent change it got that much smaller. Okay, so go ahead and do your math. Pause the video, do your calculations. You're going to need to have all of those calculations done to move on to the next part. Okay, if you are listening, you need to have this final data table done. The math is part of your lab. So if you have questions about how to do the math, ask me in class today. Otherwise, go ahead and move on by turning your page to the graph. Okay, so your graph looks like this. Every graph needs a title. And we know that this is an osmosis lab. Don't title it the same title as the lab. So you might want to wait until you've graphed and you know what you're graphing, but you're going to need a title for your lab, or your graph, so that anyone looking at the graph would understand what it's about. Okay, potato lab, osmosis lab, not quite specific enough. What about the lab are we graphing? So that's why you might want to wait. Okay, so to set up your graph, the x-axis is the solutions. So remember we had the 0% cup, the 5%, the 10% sugar, the 15% sugar, the 20% sugar. So these are those 5 cups. Okay, if you look back here, see I have 0, 5, 10, 15, 20. Great. What you're going to put on the y-axis is how much the potatoes changed mass. I'm not sure if you can read this here, but it says percent change in mass of the potatoes. So that percent change in mass, that very last number that we calculated, where my sample that I calculated was negative 10%. You're going to graph this last row only, the percent change in mass. That's the row that you're graphing on the y-axis here. Okay, so it is your job to set up your y-axis. You need to look at your numbers and figure out what is your largest number and what is your smallest number. Your smallest number is going to be one of the negatives. So when you're setting up your y-axis, you'll actually have a negative number right here. You can figure out, make sure you know how much each one of these boxes is worth. You'll have a 0 in here somewhere, and then the numbers will start being positive. So even though a lot of times graphs have 0 at the bottom right here, we have a negative number. So your 0 is not at the bottom. Okay. Your 0, I will tell you when I did this, let's see, my 0 I had as right here. You might set yours up that way. You might set it up slightly different, but your 0 is going to be partway up the y-axis. You need to make sure each box is worth an equal amount, like maybe let's say 1%, whatever percent you want to set each box as. You need to get your y-axis as high as the highest number and as low as the lowest, most negative number, so that you can graph all of your points. Okay. Once you have that, you can follow your instructions on the procedure, but you will actually plot your points. So for each percent of sugar, the cups, you're going to plot your point of percent change in mass. Okay. Your instructions will tell you to draw a best fit line to see your overall trend. Once you've done that, you're caught up from what you missed in class last time. You can see me in class or see tutorial part 2. So that should be enough time to start on your graph, and we'll check in after that. Thanks.